With Diwana, and this is Day-9 of our Kubernetes Hero series. And today we will master our four production level topics, that is of CNI, means of cluster networking, and NGINX and Ingress NGINX, and also like a persistent volume and PVC, and a liveness and readiness probe. So grab your terminal, let's turn you from a beginner to a pro level. Before we jump into the demo, let's test your DevOps brain with a 5 or scenario-based Kubernetes question, right? So, question number 1 is, why is your app showing a 404 in Ingress even though your service is working perfectly, right? And question number 2 is, your pods restart or rapidly every few seconds. Could it your liveness probe is killing it? And the question number 3 is, your pods are running but your services are not response. What's so wrong with your readiness logic, right? And question number 4 is, you delete a pod and suddenly your all upload of vanish. Did you forget to use a persistent volume? And the question number 5 is, how did you expose a multiple microservices behind a one domain, just like a production? So cannot answer all of them right now, but don't worry, by the end of this video you will answer all of them with a real hands-on. So before we move into the demo section, please hit a like, share and subscribe to Tech With Diwana, because your one like is really motivate me to create such amazing DevOps content for you. First is a CNI, means a cluster networking, right? So every pod in Kubernetes gets its own IP, but who gives those IP? And the answer is very simple, that handled by a CNI plugins like a Calico, Flannel, Weave or a Cilium. They connect port seamlessly across the nodes. So CNI means a port-to-port communication engine. So let me show you the how you can check. So see here, I have already installed the Minikube status. So see Minikube status. See. So see, Minikube is running right now. So I already told you how you can install the Minikube on your local Windows system. So I will not just tell you the steps in this video. So let me show you how a CNI establish a port-to-port communication. So how you can check a networking of the any port. So see, I will check kubectl get node -o wide. See, so here see how you can check IP address, kubectl get pod -a all -o wide. See, so see all the here like a pod and its IP address, right? See, and also I can check from I can say just like a kube system. So see kubectl get pod -o wide, right, -n namespace cube system. So see all the IP services with IP. So see here the etcd cube API server, and see the IP address, right? So see, in this way you can check every like a pod, and it so every pod gets its IP inside the CIDR range. So you can see check how a CIDR range, and this is the command, and I will share this command in the a video description. Easily you can get from the easily, right? So see here actually I am getting an error because just like I say, this is not a commandlet function, right? So see, let me switch here to PowerShell to Git bash, right? You can do these things from your side. This is not a very tough thing. Let me show here you once it is started. So see now, let me hit that command. Will be grep or cider and represent it. So see what exactly a pod cider is. So see, CNI basically means if this network breaks or pod cannot communicate to each other, right? So this is a cider, and how you can define a cider. I will share the everything command in a GitHub repo in the video description, and you can find out easily them from there, right? So in Minikube or default CNI plugins handled by CNI networking, right? So not a CNI, it is a pod networking. So it is a not required a manual setup here because we are using a Minikube. Second is Ingress and NGINX Ingress, right? So services can expose the port, but when you have a multiple application using a many node port, that is messy. But that's where Ingress and NGINX Ingress comes in, a single entry gateway that's route or traffic smartly. So Ingress and NGINX Ingress, right? So we are using a Minikube, so we don't need to install Ingress manually here. We only just enable here a Minikube command, so we will enable it, and also further we will create here actually deploy a two application, app 1 and app 2, right? So in one app I will use nginx and second in apache, right? So after setup of the two application, and we will use ingress resource to our traffic route to two applications. So we will set up this in this scenario. So see how you can actually enable the ingress in a Minikube. This is a very simple command. You just click here Minikube, add on the enable ingress, and it will be enabled for you. So I have done it. See, so it will be enabled for you and you can use it. So further I will create a deployment and deploy a two application using just like a node port. So see, once ingress is enabled, just create a two deployment, app 1 and app 2, and further we will set up just like a ingress resource, and you can see how a ingress resource can handle your traffic, right? So see, let me hit a command to create a deployment. So see here, very simple, kubectl create deployment app 1 nginx, right, and app 2. So see actually see this is a very simple, so I don't need to explain everything here, because so see, this is a very imperative command. So we used earlier in every episode, kubectl create deployment and name of the deployment app 1, and image is a nginx, right? And this is a dry run, so it will just create app1.yaml. So see here, right? So in this way I have created just like app 1 for nginx and app 2 for httpd means apache, right? So now and also expose this service using a internal as a node port, right? So also expose these services over here, app1.svc, you can see from here, right? So created the deployment and expose it internally, right? So see, and now I will create ingress resources. So see, this is an imperative command, kubectl create ingress, and the name of the ingress is a demo ingress, right? See, and the rule is a my app.local slash app1 colon 80, means someone visit on this URL and it will be directly redirected to nginx. Why nginx? So see, I have already mentioned created a deployment app 1 for nginx and app 2 for apache, right? So see, ingress networking k.io is configured right now. See, kubectl get svc. Let me check. So see, that's fine. App 1 and app 2, that is using a cluster IP for internal, right? So kubectl get deployment deploy app 1 and app 2. That's a time meter 3 minutes ago. So see our deployment and the services right now set up. So these are what you can do on your system. So you can find the public IPs of the like a Minikube, and you will set up just like a host path in your Windows system, right? So see, you will find on your Windows system just like this path. Let me hit here. See, uh, just like a Windows System 32. So you can just type, let me see in our notepad so that you can get really understand how you can set this. So let me show you just like my notepad so that you can get really understand what exactly I just to show you. See how you need to do. You just need to find a C Windows System 32 driver etc host, and you need to enter here just like a 127 in place of the your Minikube IP. So you will put here, you will put there a Minikube IP, right? And it will be just like a work on your local system. So let me back to my VS Code. I have done this. You can do this on your system, right? Let me back here. So actually I have updated the like a host file, and let me show you what exactly we need to find to see by the deployment. So let me hit just like app1, app1, app1 dot app1 and app2, right? So mm, just I told you that how actually is my app dot local. So see actually my app.local, right? So this is our DNS. So it is a locally point to our local host. So we will hit on this my app.local and slash app1, then it will be redirected to a like a nginx, and app2, so it will be redirected to a like a Apache. So let me share my browser to you, and so we will check how it will work and redirect, right? So see, wait, open. Let me show to browser to you. Minute. Yeah, just open now on setting to you. Firefox. So just yeah. See, yeah. So I will open just like app one and app two, and you know the DNS what exactly, right? So see app one and my app one and app two. See, just hit enter. See, it will be so nginx. So see what exactly we need and how you know actually ingress controller is redirected for your request to a app one. So see, this is a app one. Let me copy it and type here the app two. See, two. So see, it worked. This request is comes from Apache and HTTPD. So see, I have just created here auto deployment and export it and set up the rule for a nginx index controller, and it is routing our request to a like a DNS to here, right? So you know exactly one domain and a multiple application. So see, my app.local is our one domain, and here app one, app two, and the n number of the application that is managed by your nginx ingress. So see how you can use in a real time a Kubernetes cluster, and one ingress and Jinx controller can manage a multiple application. So I can create here a app 1, app 2, app 3, and many more, and you can use a one single IP to expose here many applications. That is a power of a ingress controller, right? So also you can check from here. Let me show you once again Visual Studio and how a YAML looks like. So see ingress demo.yaml. So see here what exactly are defined inside over here. So see spec, So see, a rule is created like a host myapp.local, and the path is https, and path is a backend. So see, backend, and the service name is app1, and the port is 80. And you can see also here just like app2 and part type the exact. So exactly of this is a ingress controller define how a syntax you can define in this way. So I have not remember anything. You see, I have just do in front of you how we can run a Trident command to generate a ingress controller YAML or any of it, right? So let me move to a next demo. Third is a PV and PVC means a persistent volume and persistent volume claim. In Kubernetes, ports are temporary, but data should not be. That's why we use a PV and PVC. So PV is the disk and PVC is the request. So let's create a PV and PVC, right? So let me clear you one thing. PV is required for just like a application type or Kappa, Zookeeper, and like DB, MongoDB, where a persistent data is needed, like a stateful set application, right? So in a stateless, you can use like just like in a pod, if you are running any pod, like something that in a stateless application. So this type of application in which your data persistent is needed, that's why you can use a volume, right? So let me create over here how you can create a volume PV and PVC, right? So PV is defined like a disk, like a storage. In a real time, you can see or you can use or just like a NFS, like a storage like any SAN or any like a just partition of any disk like a NFS of the Linux server disk. So you can define over there your application as per requirement. So in a real time, not just use for a one port for a, like a persistent data in a like a storage. So let me show you how you can now set up a persistent volume and how you can use that in your as per requirement, right? So see, let me hit this command or just like a run. So it will be created like a PV and PVC, and I will create a disk of 1 GB for a PV, and claim is I will set up a claim for a just like a 500. So it will be mount like a date MNT and disk part of our system. So in a Minikube or dynamic provision in a Minikube or just like a PV is just defined is like a storage like a dynamic provision. So you don't need to set up anything as per required to you. So see, in a Minikube or dynamic provision is controlled by your just like a provision controller, just handled by your storage provisioner. So let me show you actually how you can create, and I will everything command I will paste on the like a GitHub and also share in the here, so you can find in a video link description. So see, this is a very simple command. See, once it will be created. So see. So this is a Trident keeps it is a create -f and Trident over YAML, and name is this, and inside of this is a like a define over here. So see what exactly API version, kind persistent volume, and name is a like a mypv, right? So access mode or read write, a capacity is a 1 GB as just I told you, and the path is a like a MNT data, right? And claim is here define a mypv, mypvc, and the storage define of 500 M, right? See, let me try it to see. You can check kubectl cat pv. See, kubectl cat pv and pvc. Okay, let me apply it. Kubectl apply pv, right? So did not apply it. Cube missed command here. Kubectl I have PV. So see, should be done. What happened exactly? Y minus F, Y minus A. See, is just now created. So C Q C L get P and P, right? See? So see here, exactly drag it here, right? So see, just like a age is just showing a 17 second and name is a persistent volume, and see the capacity and the access mode is a read write as mentioned over here in the manifest, right? Retain, bound, claim, what exactly of everything defined here, how you can set up or create a PV, how a claim is defined over here. So it is a requirement by some application who needs like a persistent data, as I told you, like a Kafka, Zookeeper, and like a Kappa Zookeeper, and you can say that just like a one more, and like just a DB, just like a MongoDB. So data persistent needed for that application. To see you how you can set up a persistent volume, how to claim it, right? So actually, inside the application of PV is created in the part of define any specific application that will be used like a PV and PVC, and you can also check it through just like a creator one or just like an NGINX application, and you can also define the inside of the like a PV path, so it that port would be save the data inside of PV. So that is not a logic to use, or just like I will show you to how NGINX is showing a persistent data in your volume. That real time scenario is totally different. So don't confuse, it is just simply to use to store or data persistent as per requirement of the application. Whatever you can use it. See? Fourth is liveness and readiness probe, right? So how does Kubernetes know your application is healthy? Through the liveness and readiness probe, right? So liveness check if container is alive, a readiness check if it is ready to receive the traffic. So let me set up last is like a liveness and a readiness probe. So I will use here one NGINX board, and you can see how a liveness and readiness probe is defined by you as per your application requirement, how a application is useful production. So you can create a manifest to define a liveness and readiness probe as per your time requirement. So see, I will just set up here one very simple. So I will create here just a dry run command to use the NGINX image. You see, right? So here, see, probes demo.yaml, right? Okay. So see a version, kind, metadata, and labels and probe. So everything as per requirement is mentioned here. So see, just let me enter here liveness and readiness probe. So this is just for NGINX, and you can see like a spec on NGINX. So let me here updated just like a liveness and readiness probe. So see, EPA version B1 kind pod, and metadata is probe demo. And I have just added here a liveness probe as HTTP gate, and path is the route, and port is 18, and initial delay is 5 seconds, and here is the initial delay is a second 3 second, right? Control S, we apply it, L I, and I will paste everything in a GitHub repo so you can find it easily and can understand it. If you didn't find, let me drop in a comment section. Q L I minus F O YAML, hit enter. See a pro just now created. So let me check is set up or not. Let me verify it. So see, just liveness is a delay 5 seconds out failure of 3, and readiness is this and success and failure of 3. So this is how you gonna get and you gonna find it. So in this way you can set up as per your requirement of how readiness and your liveness is requirement. So you can set up everything. Or this is not a very advanced thing, so you can understand easily. And I have created here like how a dry run command to run to create any YAML, so you didn't get a confusion of anything. And in front of you I have not written any YAML and not remember anything, just like a grep or concept. Once you get a grep or concept, you can write easily and anywhere. If anybody can ask you, you can definitely answer them how to create a YAML and what is a basically ingredient of it to write a YAML, right? This session you have mastered how your cluster connect through a CNI, routes or traffic via Ingress, store the data using a PV and PVC, and also like auto health itself using a liveness and readiness probe. These are the true pillar production of the Kubernetes. If you find this video is helpful for you, please hit the like button and subscribe to Tech With Diwana. Let's see you in a day 10 where we will start like a multi-tier web application deployment and like a jobs and clone jobs. So let's see you in a day 10.